So Usman is an environmental economist at the Namibian Nature Foundation. And prior to joining the NNF, which is the Namibian Nature Foundation, he has worked as a technical advisor at the Environmental Protection Agency of Liberia. During his time here, he provided guidance and support on issues related to climate change and capacity building. He's an economist by training. He has a B Science honors in economics from the University of Warwick and an MSc in environmental economics and climate change from the London School of Economics. So I see on the program, he indicated that he's going to talk about the natural capital of Namibia as a marine environment. To be specific, for his presentation today, is going to look at the marine ecosystem services in Namibia. Without wasting time, let's welcome Usman Khan for his to give us a very good presentation. So welcome, the floor is yours.
Thanks so much. I really appreciate the offer being extended to me to present. I don't think I'm going to use that entire hour. This will be relatively short, but just covering, the majority of the economic aspects of ecosystem services. So thanks so much for joining, everyone. In terms of a rough outline of this presentation, I'm just going to take you through an overview of ecosystem services, their linkages with human well-being, then into how and why economic valuation has a role in this, then setting out a framework for this, and looking at the methods that can be applied to elicit values. We'll then look at the work that has been done in country, and finally we'll touch on the work that I'm currently doing at the NNF in conjunction with the Southern Atlantic Environmental Research Institute, so that's SERI, and under the support of the One Ocean Hub program. So in terms of an overview of ecosystem services, in terms of definition, ecosystem services, they're the benefits that individuals accrue from the natural environment and from properly functioning ecosystems. When we speak about this in a marine context, it's obviously the benefits that people are obtaining from coastal and marine ecosystems. And in terms of classification systems, many competing classifications exist. And I've just here listed the ones that are most commonly used. It all really kicked off with the Millennium Ecosystem Assessment in 2005. So that brought the conversation on ecosystem services to the fore. The key finding of the MA was that currently, or now we're going back 15 years, that 60% of ecosystem services evaluated were being degraded or used in an unsustainable fashion. And, it's likely the case that this is much higher today. This was then followed by the economics of ecosystem services and biodiversity, the TEEB, in 2007, which really placed an emphasis on the role economics played in valuation. Both of these classification schemes break down ecosystem services in four main categories. You have provisioning, regulating, supporting, and cultural. In terms of provisioning, in a marine context, this is tangible products from the ecosystem. So food, through fishing activities and aquaculture. You have water storage and provision, biotic materials and biofuels, so medicines, biomass for bioenergy, and the like. In terms of regulation, this category refers to benefits that people obtain from the regulation of ecosystem processes. So among other things, we're talking about air quality maintenance, climate regulation, erosion control, regulation of human disease and water purification. In terms of supporting category, we have got the provision of habitats, primary productivity, nutrient cycling, and soil formation. Last but not least, you have cultural services, and these embody symbolic aesthetic values, recreation and tourism. Now, I primarily touched upon the MA and the TEEB, but more recent classification systems such as the IPBIS and the Common International Classification of Ecosystem Services have been introduced, and they've sought to strengthen the science policy interface for biodiversity and ecosystems and try and overcome this translation problem between classification services. Because if you take a particular service from one classification system, it may not necessarily match another. Another key distinction between the first two and the latter are that the supporting category is not included with the IPBIS and the CICES, because those are of the view that supporting services underpin a range of other service outputs, as opposed to being an outright category. So there would be fears of double counting. And so look, we've said that it's clear that the marine environment provides all these different ecosystem services, and they really do need to be protected because they're not only vitally important from an ecologic perspective, but also economic. They're being degraded at a rapid rate due to habitat destruction, land conversion, pollution, overfishing, among others. And more recently, we're really seeing a focus for policy and management interventions from global to local levels. So I guess I've briefly touched on why we should be bothered about this. Ecosystem services and human well-being, they're intimately linked because our well-being is linked to the availability of these services that are provided. If you take, for example, food security, employment, disease, disaster, these are global issues, but acutely impact those poorest in society. And how the Millennium Ecosystem Assessment has defined well-being is as the basic material needs for a good life. You can see on the right-hand side, this graphic has been taken from the Ecosystem Assessment Report from 2005, and it's charting the different categories of ecosystem services and how intensely they're related to constituents of well-being. So given that these are of important need to humans, there's a real importance to understand what's at stake in terms of these foregone economic benefits. And there are a variety of tools that exist to support the application of these policies. I'm purely just going to focus on the economic valuation side. I'm not too familiar with the backgrounds of the participants today, but this may be an unfamiliar concept, but I'm almost certain that people have internally done some economic analysis, because it's the case that every time we do make a decision that affects the way in which the natural environment functions, we're putting a price on the value of the environment. Economics fundamentally is based on the premise that there are unlimited wants and limited means. And this in turn means that there's scarcity, and necessarily there are policy and management decisions that need to be made that involve trade-offs. So for example, we can take the protection of an ecosystem through a ban or a reduction in some type of activity. This in turn, while it may have an increase in ecosystem services, it may lead to a reduction in other services that have been provided by the restricted area. And what the economist here is trying to do is bring this information to light and make the trade-offs explicit so that they can be presented to decision makers and they can understand, how clearly how the loss will affect human well-being in the short and long term. And economic valuation studies have, in the past, presently, and in the future will be used to support marine management decisions and conservation policies in a variety of ways. So I'll just, there's a list. It's not comprehensive there, but I guess I can just touch on a few. Okay, so in terms of how these economic valuations can support marine decisions, we're evaluating environmental, social, and economic impacts of proposed developments or policies. These in turn can be used to justify or advocate for policies that seek to restore or protect coastal ecosystems. And in doing so, you're raising awareness of the value of these ecosystems. At a more national and financial level, this is an opportunity to extract finances from coastal economic services. So there are payment for ecosystem services schemes, but then finance can be used to protect these regions. And I'll touch upon that work later on. Costs and benefits of different coastal environments of uses can be conducted. So you're essentially assessing the different trade-offs associated with each. And this can include a distribution of effects among winners and losers. What the work that I'm trying to, with my team, hopefully, is to inform marine spatial planning processes, because these often can include multiple and sometimes conflicting uses of the coastal and marine environment. So having that economic valuation of ecosystem services in place can really inform proper management. But I'd like to make it clear that, economic valuation is not the be all and end all. There's no correct answer. All that we're trying to do is provide information that can facilitate more objective decision making. And that the work that is done from economists or economic valuation, it's taken in the context of sustainable development, and a long-term view is taken. This is not just going to affect individuals today. They're going to be winners and losers in the future. And it's not just impacting the coastal communities. When we take a view of climate change, this is a global phenomenon, and it will impact people who are on the coast, but also inland. So I think I've tried to make my case there for economic valuation as a tool for policy, but this needs to be put into a wider framework within which we can view it. And when we look at economic theory of valuation of natural resources, it typically calls for a comprehensive compilation of all values. And not only that, it's quite clear that a single person is not just benefiting in one way from an ecosystem. There are multiple services that they can benefit on. And the total economic value approach illustrates that fantastically, really. It presents a roadmap that can facilitate this mapping of ecosystem services and provides a really good checklist for the economist to make sure that all these different values are incorporated in the valuation process. You've got a graphic here which does a really nice job of illustrating this. In its simplest form, the TEV distinguishes between what we call use values and non-use values. Use values are those associated with current or future potential use of an environmental resource. So it involves some kind of human interaction with the resource. Non-use values, on the other hand, arise from this continued existence of the resource and are not related to the use. I'm going to flip to the next slide so we can see a more detailed explanation of what we refer to as use and non-use, and then go back to that diagram. When we talk about use values that are based on actual interaction with the environment, these comprise of two different values. So you have direct use value and indirect use value. In terms of the former, this involves individuals using the marine environment in an extractive way. So the example here is fisheries, or it can also be in a non-consumptive way. So recreation at the beach, or tourism, or environmental education. Indirect use values, on the other hand, are individuals benefiting from these ecosystems, but rather than use it, they're supported by it. So the examples here are carbon sequestration, erosion and flood protection, and water purification. You can see non-use values, they're simply associated with the knowledge that the natural environment is maintained. So I don't necessarily have to be living on the coast, but to know that, the marine environment is intact, there are mammals and there's plenty of marine life living, individuals can derive value from that. And this can be broken up into three different categories. You have altruistic values, bequest values, and existence values. But they all relate to this idea that the resource is simply there. Going back to this now, you can see that the diagram comes along with this accompanying scale at the bottom. And this neatly kind of summarizes the ease to which it is to value some of these uses and how visible they are. So it's clear that when we're interacting with the environment, we can clearly see it. Whereas just having this notion that something is around, you might not necessarily be able to value that. I'd also like to touch on this idea of an option value, which is it's a combination of both. It's this premium that's placed on the idea of having a resource available in the future that may be used. And typically in the marine space, this perfect example would be being able to know that there'll be a resource in the future that could be used to create antibiotics or something. I think I'd also like to make it clear that the total economic value approach is a conceptual framework, and when economic valuations are conducted, they may not have the means to value all these different uses of the environment, because there can be restrictions on data, on methodologies, and the like. But in terms of what we can value, broadly speaking, you have three, a number of economic valuation methods have been developed to estimate the value of changes in the provision of environmental goods and services. And these are broadly in three camps. First off, we have market prices. So these are what we call market-oriented techniques. And typically they involve the observation of a quantity of environmental service, and simply it's a case of multiplying it by its market price. And there you've got a value. So in the marine landscape, typically, this is done with in the fishery sector. So you'll have a landed catch, there's an associated market price, and you can multiply both and you've got a value. But the challenge is that few of these marine ecosystem services are actually marketed. So we predominantly rely on non-marketed oriented techniques. And these can be separated with what we refer to as revealed preference methods. So methods that are based on observed behavior, and stated preference methods that rely on survey responses. I've just listed a few methods that, as example. I'm not really going to dig deep into them. What I will do now is touch on the two papers that are focused on economic valuations of the marine environment in Namibia, and through that I can kind of explain the methods used. So in terms of our first economic study on the marine environment, we have to go back 20 years. One feature of the work that has been done on the marine environment is that a lot of these studies are incredibly old and involved outdated data. And so, in recent times, I'm really glad that there has been a push to advance research in marine ecosystem services. But colleagues at the Ministry of Environment, Forestry and Tourism back then conducted an economic valuation of the recreational shore fishery. And here they used two methods. You have the travel cost method and the contingent valuation method. So here you can see that you have a revealed preference method and stated preference method being used. In terms of the kind of work that was done, it was assessing the value that anglers were providing to the fisheries. With regards to the travel cost method, the anglers' cost of consuming the services for the environmental asset were used as a proxy for price. So, here the basic premise is that the user population is homogeneous in its willingness to pay, and that the differences in costs of consumption result in different rates of visitation. So, these consumption costs can include the travel costs to get into the location, entry fees, on-site expenditures, any kind of capital outlay for equipment that's being used. And the idea is that by varying these travel costs and visitation rates, because people are coming from different locations, it's possible to derive a demand curve that expresses the demand for trips to the recreational area. And by doing that, you're able to determine appropriate entrance fees, etc. Contingent valuation, on the other hand, directly asked respondents how much their travel to and from their angling destination was costing and what the total angling trip was costing. They were then presented with a card which asked them, what they'd be willing to pay for a similar angling trip and whether the current trip that they'd had was value for money. Based on that, they were able to identify a maximum willingness to pay. And you can see on the right-hand side, you've got estimates for both methodologies. And they're converging to similar amounts. You can see that aggregate direct expenditures by anglers were between 23 million and 31 million Namibian dollars. And this represents around 3.5% of the whole fishery sector. A more comprehensive study on fisheries in the BCLME was conducted around a decade ago by Rashid Somalia at the UBC. And the focus of this was valuations of commercial, subsistence, artisanal fisheries, along with marine recreational activities and mariculture. And the basis on this was that, the fisheries industry is an integral part of the Namibian economy. It's right behind the agricultural, and from an economic perspective, the fisheries sector is an incredibly important part of the Namibian economy, and in particular, the social economy of Walvis Bay, which is the major fishing port and where most of the processing plants are situated. So, a bit of history. Local employment in the sector grew rapidly after independence in 1990, with roughly 6,000 jobs being created between the period of 1991 and 1994. And as part of this study, the following economic indicators of value had been calculated. So catch, you had direct economic impact of these resources, the total economic impact it had throughout the economy, the income and wage impacts of these activities, and the number of jobs that were generated. So in terms of the first table, you've got indicators there for subsistence and commercial fisheries. And you can see quite clearly that Namibia, as part of the BCLME, receives the greatest economic benefit. When we refer to direct impact, this is the price at the first point of a sale the fisher realizes upon sale of their catch. So you can see really substantive figures here. And even in terms of the wage impacts to the broader economy, they're the largest in Namibia. Table 2 looks at the values from marine recreational activities. So what the authors did here was estimate the contribution of MRAs, which had been defined as activities that directly relied on the marine population, and more specifically on recreational fishing, marine mammal watching, and diving. From here, what the economic indicators of value that were constructed were the amount of participation, employment, and direct expenditure by users. And in terms of the last area of focus from this study was the mariculture sector. And here, ex-farm prices, so the price received by the farmer, regardless of haulage and other fees, were used to calculate the direct output impact from these activities. The Benguela Current Commission, which is it's established as the full-fledged regional cooperative management body for the BCLME, is currently in the process of updating these figures. And so there is, like I said previously, a lot of ongoing work on ecosystem services and their valuations. And this kind of segues quite nicely into the work that I'm currently doing. So as a quick introduction to the One Ocean Hub program, this is an international program housed at the University of Strathclyde in the UK. There are 18 partner organizations across the world with focuses on blue economy, marine spatial planning, environmental human rights, ocean culture. And essentially what the hub tries to do is produce research outputs that bring together these coastal people, researchers, policymakers. So we properly incorporate justice and sustainability in future policymaking decisions. And the NNF here really responded to our direct need to understand the value of the natural capital in Namibia. And so, we started off by, towards the end of last year, we had a scoping assessment, which I'm just going to put here. We initiated consultations with relevant stakeholders in the marine space to understand, what their priorities were when it came to economic valuations. This concept of blue carbon was repeatedly flagged as an area of research interest. And, more broadly out there, this is an interest area, which is just emerging. Beyond what you're currently seeing here, which is a compilation of ecosystem services in Namibia, we'd developed a scoping report. And for participants who'd like that, I'm more than happy to send a copy. In terms of a review of blue carbon, this is essentially just the carbon that's stored in coastal and marine ecosystems. And in Namibia, that's vegetated habitats such as seagrass meadows and macroalgae, so kelp. These habitats can be really productive and support high carbon burial rates, more so than terrestrial systems at times, particularly if these environments are undisturbed. You can see that currently there are huge threats that the marine environment is facing. There are economic pressures to convert these blue carbon habitats, but at the same time, we're seeing efforts towards restoring and protecting these areas, because it's clearly recognized now that there are not only economic benefits, but also social and environmental payoffs. data had been a bit of a challenge in terms of what exists in Namibia. And what we've had to do is focus primarily on kelp and seagrass biomes, but also we're using modeled biome distributions that were developed by authors based in New Zealand. And as you can see on the left-hand side, the model distributions, which were determined through a variety of ecological factors. You can see on the left-hand side, you've got what the modeled kelp distribution in Namibia is. So it's really sprawling along the coast. And you can see on the right-hand side, you have seagrass distribution, which it just covers pockets of the coastline. In terms of valuation, this is really it when it comes to methodology. What we want to consider is an avoided loss, an avoided conversion of carbon emissions. So the biome distributions you can see here, the scenario we want to start with is that let's keep these intact. And so how do we go about putting that into a model? First off, you need to begin with actually quantifying the greenhouse gas benefit. So that's emissions that would be avoided through a blue carbon project, that's protecting these coastal habitats. And it takes the form of the first equation here, where you've got the greenhouse gas benefit flux equaling the annual carbon sequestration rate, which continues as the habitat is retained. You've got avoided CO2, so those are the emissions that are avoided from its conversion. And then we have E, which represents any emissions that may be emitted through potential use or conversion of the land. These greenhouse gas benefit flows can then be monetized, and we can obtain our blue carbon value by multiplying these annual fluxes by a stream of expected carbon prices over a period of length n. So in terms of carbon pricing, there are a variety of literature out there. There are also existing carbon markets with respective prices that can be used. But in terms of the work that we'd like to do, we'd be interested in modeling this based on the social cost of carbon. So this is the global damage, as in when we talk about social cost of carbon, it's really to do with the damages associated with an additional unit of carbon being emitted into the atmosphere. And so I think it adequately reflects the damages associated with emitting. You then also need to discount this because we're looking at this value over a certain length of time. This needs to be discounted to arrive to a present value. And again, here, the discount rate from the economic side, there's a lot of controversy around which rate should be used. Typically, when we look at financial projects, we'll use the market rate of return. So that's, I'm not sure what that would be in this case, but it's used on the basis that, it can't be any lower because one can get a better return at the market. There are, ethical and moral considerations that could justify a lower rate, but then we wouldn't be working with the financial rate. So you have this setup, you've got this economic model, which will churn out a blue carbon value, and then we can move into an appraisal. Equation 3 here, you've got avoided conversion would be economically viable if you have blue carbon values being greater than the protection costs and opportunity costs. Protection costs here could be, increased monitoring and enforcement, and opportunity costs are the costs that previous users who had access to it, they've obviously lost out because these are areas of exclusion. And so going forward, we'd be looking to put a value on those. But it goes beyond the blue carbon. When we talk about seagrass and kelp, you know, the carbon sequestration is not the only value that they provide. And so these are the associated ecosystem service values need to be incorporated. And so really in terms of a cost benefit analysis, where we're looking at not only the blue carbon value, but the ecosystem services values with kelp and seagrass. And, you know, if it is the case that these are greater than protection costs and opportunity costs, then a decision maker would take the view that, you know, it's best protected and preserved. In terms of what's next, it would have been really nice to have had this presentation in a couple of weeks, because we've just got an upcoming stakeholder engagement, which is going to work with experts in the field to understand threats and challenges associated with these blue carbon habitats, and really to try and develop scenarios and find consensus on the different parameters for, you know, the economic and ecological values. There's also, I've not touched on this previously, and I perhaps should have, but, you know, this blue carbon interest is really at the fore because there's a growing carbon credit marketplace. When we look at the Paris Agreement and other climate change treaties, you know, there's a big focus on reducing greenhouse gas emissions and this approach to moving towards net zero. Corporations are becoming aware of the potential impact that this may have on them, and they're looking at potential offsets. There's currently some really interesting work going on with kelp off the coast of Luderitz, and the idea would be to engage these actors and really understand what role this has in the context of Namibia and the marine environment, and how this can benefit people living in coastal communities here. I think that's all. I'm going to stop there. I hope that's made a bit of sense, and, you know, I'm more than happy to take questions here. Thank you.
Okay, thank you very much, Mr. Khan, for that wonderful presentation. Although you are coming from a different area of expertise, I really came to appreciate your overview on that topic, especially the benefit associated with economic valuation of ecosystem services, especially from a marine ecosystem point of view, and for providing the methodology on how ecosystem services can be valued or monetized, make it even more interesting. Yes, I can leave it here and take questions. You can write on the chat or unmute and just pose your question. Yes, Kraina, I hope I am pronouncing your name correctly. Go ahead.
Yes, thank you. I think what your presentation was very interesting to me. It's always a bit Greek, I must say, because it is so difficult to put an economic value to the marine natural environment. But I think what your presentation showed is how important it is to have baseline data. You know, if you look at your maps where you model the kelp distribution and the seagrass, you know, I would really be interested, and I know that's a big shortcoming, that we don't have the baseline data, and a model is of course only as good as the data that you put in. So basically what I want to say is that I think all these projects should not forget that very often collecting baseline field data is very important, and I see that with many projects that they don't cater for that anymore. You know, they work with what we have, identify gaps, and just carry on. And I think yours shows really that baseline data collection is very important. And I think that's that's a comment I make to the UNAM people as well. I think we sometimes forget how important the actual field work is in order to build on for all these other important things. Thank you.
Thank you for that input.
Sorry.
I see there's a question on the chat here, but before I go to Annette, I just wanted to find out from Mr. Khan, with regards to mariculture, I see Namibia compared to South Africa, I think, and Angola, Namibia is not doing well. What do you have to say? Maybe South Africa and Angola are doing that Namibia is not doing. If you can maybe just highlight on that.
That's an incredibly difficult question for me to answer, I think, because I wouldn't say I'm an expert in that particular field. But I think, it's also worth bearing in mind that that study by Rashid Somalia was done in 2011 based on data that are coming from 2003. And, it may be a different case now. So I think it's worth just waiting to see what the colleagues at BCC develop with their reports. They're currently in the process, but, they might be able to shed a bit of light on that. So I'm sorry, I'm not able to answer that fully. But I'd like to, completely agree with Anya, and, it was a struggle even finding this data set, and this is model data. So what I'm hoping is that hopefully this can set some kind of baseline and encourage work that's done in terms of habitat mapping, because I appreciate fully that these are incredibly costly processes. And in terms of the budget we have, we're restricted to just conducting this economic analysis. But there is also that real fear that some models, if they're based on unreliable data, you've essentially got a GIGO, which is garbage in, garbage out. And I certainly don't want the work that we do to be in that bracket. So what we are trying to do, at least with the ecological and economic factors, is rather than focus on one particular value, it's having a range, because the work that's being done on kelp, it's fairly emerging research, and there's a lot of attached uncertainty. So if we're able to capture a range of values that appear in the literature, it's best to be more conservative. But I fully agree. A lot more research needs to be done in terms of collecting these data. And this is just a general problem for marine ecosystem service work. If you see the terrestrial counterparts, they're light years ahead in terms of methodology, in terms of data availability, and the like. But I'm hoping, in the coming years, there'll be a big push.
Okay, so there's another one by Annette. Can you shed more light on how the carbon credit system works? That's from Annette.
Yeah, so I mean, I can give it a try, and I can probably give a more detailed response offline. But essentially here, how these schemes work is that the focus also is predominantly on restoration activities. So it's not that the distributions that you've got, you're trying to expand that. And how organizations can tap into these by restoring them, these habitats, that in turn, will sequester units of carbon. And typically what's done is organizations follow certain standards out there. So there are registries like Vera, American Gold, I think. There are a couple others under which, under strict processes, you can sell a carbon credit. So you've sequestered a unit of carbon, you can now sell that to an interested party. So here, we could take mining as an example. They have a lot of activity on the coast and associated emissions. They may not be able to reduce those emissions in-house. And so what they'll do is purchase credits from someone who's restoring the landscape. and that's then taken as, you know, towards their emissions reductions. That's my kind of explanation on the spot, but you know, I'll give a more a detailed response offline. I can take your email.
Okay, thank you. There is a hand by Kurt. Could you just go ahead?
Yeah, thank you very much, Usman. Was interesting. I'm not an economist, but that's exactly what I expect from an economist, to put the price on things. Now, let me ask you first one question, because you distinguished between use value and non-use things. Well, so what's the use value in your calculation of a cormorant?
So I didn't catch the last word there.
That's a cormorant. That's a bird that's very common in Namibia. Eats a lot of fish. What's its use value? Or does it have a non-use value?
So I mean, this would be from the perspective of the individual. So as a human, you'd be using a particular economic, an ecosystem service, and you derive value from that. So how would that work in this context? Is there?
Well, the fisherman would say it has a non-use value. It's not valuable for him because it eats fish, right? But my question more directs towards, when we use the word services, we always think services for whom? For us, right?
Yeah, of course.
Human-centered. But what's the service for a cormorant to live in the Benguela upwelling system? Great. I never find so much food here. So the services for the cormorant are certainly a very useful value. We would not agree necessarily with the cormorant's opinion. So these are the difficulties I have when an economist puts a price tag on things that might not be useful for us. How do you account for the real ecosystem value? Because the cormorant is very important for the ecosystem.
So I completely agree. I try not to be in this bracket of economists that, you know, is purely set out to put a monetary tag on these services. But you know, the majority of this work, this framework it's anthropocentric, right?
Correct.
You know, because we're talking about the linkages between the services and human well-being. If there are things out there that are of no value to humans, they would not, as far as I know, or as best I understand, they would not be incorporated in these kinds of assessments. But if you're saying that as part of the broader ecosystem, they're providing benefits, that could surely be included in, you know, regulating or supporting services, right?
Absolutely.
It's not that an individual is directly deriving benefits from it, but you know, if it's, I'm not really sure. So again, apologies, I'm not familiar with the cormorant here, but you know, it probably serves a useful function in that environment, and so it would be factored in some sense. It would have to be factored through one of these other services for sure.
Correct. I guess I made my point because Anya and Hilka are already putting up their hands.
Yes.
Hopefully in opposition to my opinion.
Okay, thanks for that explanation. There's more questions coming up. Dr. Njaula, can you go ahead?
Thank you. Yeah, thanks for a very interesting talk, Mr. Khan. I think I would want to just get help from you in what I find a very difficult position, for instance, for Namibia, where it seems most of our values or our ecosystem values are determined from external forces. As such, the locals, be it through their small voice or through their small population or small activities, the value which at times is so huge for them doesn't really come out, because if it doesn't find value externally, then it becomes no value. How would you see this process in the Namibian context? Could be weighted such that the external overweight of what is valuable and what is not valuable can be accommodated or can be sensitized. Thank you. I hope it's a question clear.
Yeah, so I think I broadly follow the line in questioning, and I completely agree with it. So it's, you know, this idea that perhaps cultural values that people on the coast have are not well documented, and you know, those in turn are not translated into values. I think that this isn't just it's not just the case in Namibia. Cultural values are quite hard to elicit in general. They typically require slightly more sophisticated techniques, and you know, a lot of the work that's been done in the marine ecosystem space from the side of economics is focused on what I refer to as these market-oriented techniques, just because they're easy to do. And obviously you have huge price tags attached with that. So fisheries is the one. I probably should, I ought to plug the One Ocean Hub program here, because they're doing not just the work that I'm doing. There are some larger projects, long-term projects that really are making sure that coastal voices are being heard. I'd strongly recommend engaging with them and learning more about the work that they're doing, and you know, hopefully in turn that can turn into some economic valuation work too. But I completely accept the point that coastal communities' voices are not being valued to the extent they should be.
Yes, you can go ahead, Anya.
Okay, mine is, I think, a bit of follow-up on to Kurt, but also I thought about it when you presented the Barnes paper with the benefits of the recreational fishing. In these kind of calculations, should you not also take into account the, what's the opposite of the benefit? The sort of damage that things done, and you know, the recreational fishing, we know, loses a lot of fishing gear that damages birds, and that's where I get back to the cormorant. So it also does damage to the ecosystem. So how does that calculation work? And then secondly, just a comment to what Annette has asked about the credits, carbon credit system. In that system, are natural carbon CO2 sources like our Northern Benguela taken into account? Because I think Tim's presentation made it clear that the Northern Benguela is actually a carbon source and not a carbon sink like the Southern Benguela. So we should not be too generous in selling carbon.
So on the latter, that I unfortunately missed that presentation. So I definitely need to reach out. I wasn't aware of that. But I mean, in terms of the kind of premise for offsetting, the idea is that you'll start off with a baseline. So in this case, you know, if we're saying that the northern part is a source, someone will come in and essentially restore that landscape. So in the case that, you know, the stuff that I'm working on with the kelp and seagrass, you know, someone could come in and plant masses of kelp. And what this is hopefully doing, you know, is sequestering carbon, burying it over the long term, so that we're turning from a source to a sink. And it's that those, I guess, the amount that you've stored can then be marketed. So, you know, it always starts with that baseline. So if it is a a source that needs to be recognized. And then on the point of the costs associated with these recreational anglers, you know, if an exercise in valuation is to be done, when we get to appraisals, you know, we're not just talking about benefits. These costs need to be incorporated, and at the policy level, when you're doing cost-benefit analysis, I would expect that this is done. I guess that the study that was done in 2002 primarily just focused on the benefits, and I mean, reading through it, you know, there was really no recognition that there were associated costs, but you know, that should be done. I completely agree, and usually thorough analysis does incorporate that.
Yeah, you can go ahead.
Anyway, Usman, the key word in your last comment about the kelp, the key word that you said there is hopefully. Hopefully it gets deposited and put away. At the moment, that's a very interesting and nice topic to study these huge biomass plants that we can see. But do we also get that much research done for those plants that fix thousands times more CO2 from the atmosphere? Mainly the planktonic green organisms that photosynthesize. They are much more important than the kelp. Why are they not considered with the same emphasis as the kelp is being considered right now?
I think that's a great question. I don't know how much research there is out there on in terms of strong evidence. I mean, when I started first looking at these this idea of carbon sequestration and carbon markets across the world, the projects have predominantly focused on mangroves. There seem to be pretty decent data, not on just the kind of extent of habitats, but the amount that is sequestered. Moving in as the kind of research scope expands to other ecosystems and habitats, you know, there's going to be, I mean, the biggest challenge here is ensuring that they properly understand how much carbon is being buried. And I guess the kind of literature I'm reading now, it's primarily led by a gentleman called Carlos Duarte. So a lot of the kelp research has been conducted by him. But you know, it's very early stages. I don't know why they've picked these habitats in particular. I can only imagine is that, you know, they're observable to an extent, and they can potentially be leveraged on these carbon markets. I don't know how it would work at a more granular scale. That's, you know, that's off the top of my head. But I appreciate that, you know, they're not the kind of silver bullet here. Even when we talk about this idea of carbon markets, you know, I'm really, as interesting as it is, I'm not that interested in this idea, because the focus should primarily be on preserving the current stock, because, you know, the carbon associated with that is so much more than what could be sequestered through restoration activities.
Okay, yeah, I fully agree. And part of the answer actually came from Anja Kreiner, who said that the Northern Benguela is a source rather than a sink, because much of that carbon that's being fixed right away is being degraded right away again, and the CO2 goes back into the atmosphere. But we have a number of KFF, Kelp Forest Foundation students and participants here online. Do they want to say something? Protasios, do you want to say something about your work?
Hi, Kurt. Hi, everyone. I don't know if can you hear me?
Yes, we do.
It's a good, interesting question. If I can summarize the whole idea of kelp sequestering carbon is looking at in the context of it having its own biota, its own ecosystem environment, rather. It can work in a way, it basically continues what the little micro phytoplanktons are already doing. So it's not really to say that it's going to be different from what the current phytoplanktons are doing, but it's actually increasing to what's currently happening. So we are busy currently with some baseline studies. So the only way we can tell the difference is after we have done a baseline study, and also eventually what happens after we have grown this kelp forest. Is there any difference? Is there no difference? So it's a timeline type of answer that I will say when it comes to this.